SDTS format is sort of a standardized format that USGS created using ASCII type format for the data. And I think I've mentioned this elsewhere, but basically it's a standardized format, so you would always have the same number of files whenever you unzip one of these things. But it's unnecessary in this case, because the SDTS or the DLG to shape program that we used in exercise 1 and we'll reuse in this one, it can handle the data already zipped up. So it will convert from this SDTS format into a shapefile format for us just by working with the zip file. So you don't have to unzip this, just leave it like it is here, and basically just start up your DOG to shape program. And so I'm going to do that now and then try to pull my window over so you can see it. Okay, I've got the program loaded and moved over onto the right screen now so you can see it. And basically we want to load each of these files into this box, and by having them in the same window here you'll be able to see how that works even better. So I'm going to go ahead and click on the add, and it opens up my folder search box here. We'll route over to the C drive, GIS 101, exercise 2, DOG, and I'm going to load both these files just for the sake of time. You can do them one at a time if you like, and that's fine. And it wants me to specify the output directory, and again, remember it defaults to a directory that you open those files from. And I'm going to leave it set that way because I want them to go back into that folder. It will create a subfolder within there for me so that I can keep everything separated. So I'll just say OK, and I could have clicked on use that for the subsequent cases if I wanted to, and it would have not asked me twice. So you'll see it loads those files just fine here. They're ready to process. We've already specified the output directory, so I can just click on the go button. And again, you might want to do these one at a time just so you can watch it. In this case, I put them both in there, and it will process each one of them. And if you notice real quickly, it said UTM Zone 16, and it said NAS there. And it's already gone by, so I couldn't save it for you to see. But when that dialog popped up and was running and processing, it was processing those in NAS, like in SAM, NAS format. And the reason I point this out is, you remember a little while ago I was telling you another clue for looking at the projection information. NAS is what the USGS used to describe files that they stored in UTM NAD 1927. And if I had seen an NAX, like an X-ray instead of SAM, then that would have given me a clue that it was likely to be a UTM NAD 1983. So just I don't want to confuse you with that, but when I have the chance, I want to point out to you some other clues that will help you sometimes when you're having problems finding projection information. So just to do that again, I'm going to delete what that program created, and I'm going to rerun that again for you just so you can see now that I've pointed that out. And hang tight with me here a minute while I get my program started. Okay, once again, let's do this again. Let's add those files, and it remembers the folder I was in before, so I can just load them real quickly. And I'll use the same subfolder for storing them. Now, when I click on Go, real quickly notice, and I wish there was a way I could pause it so you could see, because yeah, it used to be the computers were slow enough you could see it, take it a few seconds to process. Now it goes just quickly. But you'll notice when I click on Go, there's a dialog pops up, and about halfway down that dialog, it will say, it will give you some projection information that's going on there. And one of the clues again is that it has that NAS like in SAM. So just watch for that. I'm going to click Go again, and you can see it said UTM Zone 16 NAS 1 to 24,000. And both of those, it popped up twice as NAS. And again, probably, gosh, I want to say 95 out of 100 times you're going to find that it is NAD 1927. But in a rare case that you do see a NAX, like X-ray, then you'll know that's most likely a 1983 data. So just keep that in mind. It's not going to be an issue here on these DLG files, I don't think. but a couple of you have claimed to me that you saw the NAX, so wanted to point that out again just in case, and make you aware of where you can see that information. So the program created what we needed. If I look under either one of these folders, and again, notice the long file name, and that's what I was pointing out to you before. Look how long that thing is. And you could change those if you wanted to make them shorter. That's fine. I'm just going to leave them in this case because it's vector data and it shouldn't be an issue. But it is handy in a way if you had a bunch of these. If you were doing them for the entire state, for example, then this folder structure would make more sense because you would be able to tell which quad you were working with and which DLG type of data it is, whether it's hydrography or hypsography and so forth. And then these other numbers are even more detailed naming codes for the county and things like that. So this information would make more sense if you were mass producing a lot of this data. So if we look in either one of these folders, again, we'll see a variety of shape files that got created. We see a document file that is actually a metadata file. I can open that metadata file up and look for some verification in what I was telling you a minute ago. And that file might not exist. That's why I wanted to mention it back there before. But in this case, it does. And it's really handy. It tells me that it's ozone 1 to 24,000 when it was created. And lo and behold, here it gives us the reference of UTM. And there's our datum, NAS, like in SAM, which tells me that it's stored in UTM 1927. And again, if you see it NAX, that would be 83 datum. So keep that in mind. And it gives me, of course, the all-important zone as well, which is 16 in my case. Some of you are working right around the Knoxville area, and somewhere in that area is where it switches over to zone 17. So be careful that you notice the correct zone and be consistent when you define everything for that particular quad, because you'll want to make sure that they're in the same zone. So we've got our projection information. We verified it there twice now, even though it wasn't technically in that metadata file initially. The metadata file that got created here, which was basically pulled out of that SDTS format and regenerated here for us as a doc. That's what the DLG to Shape program did for us. So that's great. It didn't actually create that file. It basically pulled that information out of the SDTS format data and generated that doc for us. So very nice that it does that. Now, when we look at the shape files, again, you'll remember from earlier exercise that we have several different ones in here. And the ones that you're going to be interested in for now are the ones that end with the LEO1. Okay, so we're interested in those three, which is really one shape file and the associated files that goes with that, the DBF file for the attribute table and the index file. And we have other sets in here, NAO1, NEO1. For now, don't worry about those. If you're curious and want to open them, feel free to do that just to look at it. You'll find that there's bounding polygons for the quad. There's nodes in a lot of cases for intersections of that particular data type. There's some useful stuff there, all generated with the SDTS to Shape program. I'm sorry, I keep saying SDTS. I meant to say DLG to Shape program. And they can be useful for a lot of different things. But in our case, for now, we're just going to worry about the LEO1 files, okay? And so we've got that for the hydrography data, and we'll have that same thing for the hypsography data as well. Here you can see the LEO1. And it creates the unzip folder, which again, it's blank. It's just an extra folder that you can delete if you like. The program doesn't delete it very well. And to be consistent, now that we've processed that data, let's take our archive data out of here. I'm going to cut that out. This all saves space in the eventual zip file that you're going to make at the end of this exercise. So I'm going to take it out of there and just put it in the archive folder. And so while we're here doing this, let's go ahead and do the same thing for our DOQ and the DRG data. Those were zip files as well. Let's go in this case, we don't have to process those. We just have to unzip them. So I'm going to go ahead and unzip those files. And after I unzip it, I'm going to cut this out and put it over in the archive folder. And in this case, because I know they both have the same name, I'm going to go ahead and create one for DOQ, and I'll store that file I just cut out of the previous location in there. And again, to be consistent, I'm going to make a subfolder here for DLG, and I'm going to move those two DLG files over and put them there. Just dragging and dropping. And let's make a subfolder for the next one we're going to move over, which is our DRG. This just helps you be organized with it. And if you were doing multiple quads, this would really help. So back in our, if we go to our DRG folder, we've still got that zip that we haven't unzipped there. So let's extract that one. And then let's cut out the zip file and move it over to the archive file we just created that folder for. It's DRG, and we'll put it in there. So that cleans things up. It unzips what we need to unzip. Remember, you don't have to unzip the DLG file. The program converts that for us. But you do have to unzip the raster data. And we've moved our original zips over to the archive folder, so we've cleaned it up. We'll save some space at the end by doing that. We now have our data all acquired that we want, and the only thing we have left to do now before doing the project is go in and define a projection for the DLG and the DOQ layers. So I'm going to do that real quickly. I'm going to do that in ArcCatalog. So in ArcCatalog, since I had mine open, I'm just going to refresh my view. First, I want to select my folder that I have that data stored in. You notice if I had it in base data, it's not showing up here because I had the program open already, which is another good reason for closing it each time. You don't have to remember to do this. It can drive you nuts wondering where your file went, and all you really had to do was refresh. And when you refresh, that should pull that information up. It actually wasn't in the base data anyway. It was in the EXER2, but that would have showed up as empty if we had looked in there a minute ago. So after the refresh, it would show up. Now we'll go in here, we pick our DOQ, we select that layer, and I'm going to show you a different way to define it. So if you've got the previous video, you can go through and remember we started up the toolbox, and we went in there and we defined a projection. So let's do that for the first one here, because there's a good reason for doing it that way. But there's also another reason, another way you can do this to define them too. That's a little bit quicker. But the toolbox is nice in a way because it gives us a chance to point out the difference between defining a projection and doing a reprojection. Okay, it's popped up here, and we want to go into Data Management Tools and go down to Projections and Transformations. And in here you see your Define Projection tool. And that's the one that we want in this case. Now, after we've defined this, if we need to go in and reproject it, like we'll do for a DLG file, then there's another tool we'll use for that. And I'll show you that one in just a minute. So in this case, we just need to define it, and you always need to define it first. So just remember that. After you check to make sure if it's not been defined, and then if it's not been defined, you define it. And I knew that the DOQ is not defined, and so I started it up before I even checked to show you. But your first step would have been to check and see if it was defined, and it should have said unknown. Now we'll see that again in here, but this is the longer way to check. If you're just checking, just go to Properties and do it the way I showed you earlier. But in here, if I drag this file, I could select it from the box over here, by the way, too. But it's a little quicker to just drag it and drop it over there, and I can do that as well. And it should come up and tell me it's unknown whenever it loads. It takes it a minute to load. And look at here, it did not. It happens to be defined already. And so you're going to see this sometimes. Even, I was expecting it was not defined, and so I jumped right in here to define it, and it actually is defined. And I'm even getting a little warning, basically. This warning is basically letting me know, if I hover over that warning, it says this data set already has a projection defined. So I don't want to define it then because it's already been defined, and it's using Geographic 1983, which, if you remember back when we downloaded the DOQ, that's what it said it was in. So it's defined at least consistently with what it was supposed to be in, and I don't even have to define that one. So I can just click cancel there, not have to worry about it. So if I had checked first, I wouldn't have went through all those steps. So for the DRG, let's just check it and see if they've defined that one before we go in and open it up. So I'll go to Properties, And that I'll look in here with raster data, it's a little bit different. Your listing here looks a little different. You have to kind of scroll down a little bit, click on general, and then scroll down a little bit, and you should see here in spatial reference it's undefined. Okay, so this one has not been defined, so I do need to go through and do my defined projection on that one. So just always check. You never know. Sometimes the data provider will go through and define some of them and not all of them. And so it's hard to say 100% that all of these are going to be defined, and which is why it's better to go ahead and check it in ArcCatalog before you ever try to load it in ArcMap. Some people will say, well, let's just load it in ArcMap and see if it will know, it will warn us if it's not. Well, that's not really a good idea, because again, remember that memory effect that I told you about earlier. It's very hard to remember sometimes to save and close the program after we do that. And you can run into weird errors. So it's just a good rule of thumb to always work with your data in ArcCatalog, get it all ready, defined, and set up like you want it. Use Windows Explorer to make your folders initially, and then go in ArcCatalog, define your projections, and close ArcCatalog, open up ArcMap, and everything should work really well then. You should not see the red exclamation marks. If you get in the habit of doing that, it will help you a lot with that. So just keep that in mind. Takes a little bit longer, but it's really worth it. So we also see the unknown showing up here. So we know it's not been defined. And remember that the DRG data was in Tennessee State Plane 1983 in feet. And that's what it told us on the download site, so we're going to trust that. And so we'll go in here and click the little properties button here beside the coordinate system. And remember, we're defining this in what it actually is, what the site told us it was in. Remember, back out on my project that I created, since I loaded, I did that on purpose. I loaded that TopoQuad so you could see how it defined a projection on the fly there for it. But that projection is different, so it's going to reproject this file. If I use that same project, this file is going to get reprojected on the fly into geographic 1983, which is what that data frame was. So, and that's fine. The important thing is that I'm defining it here in what it's actually stored in. And I'm sorry if I bore you saying that over and over again, but I just really want to make that point, because it's so easy to define it in what you want it to be in. And that's not the way it works. You have to define it in what it's actually been created in. If you want it in something different, you define it here first in what it's been created in, and then you run the reprojection tool on it, which we'll do in a minute on another layer. So just keep that in mind. It's really important. If you get that concept down, you'll be 80% of the way to getting there with your projections. So here we'll go to State Plane. We want the NAD 1983, and we want the US feet. You know, if you see international feet and others, these other types with HARN and that kind of stuff, just ignore those for now. Just always stick with this one for the work that we're doing, unless I tell you something differently, and expand that. And of course, we want to pick Tennessee. And luckily for us, there's only one state plane for Tennessee. Makes that job easier. One less thing to have to look up. We select that, say OK. It loads it in there for us, and we click OK. And it will define the projection for us. It takes it just a minute. On my end, it pops up again in the other window, so you can't see it, but when it's finished on your end, you should see in the lower right, you'll see a little dialog pop up that shows the tool, and it tells you that it's defined a projection. And it takes it a little while on this first one. If you're defining 2 or 3 of them back to back, then the second one will go a lot quicker. So give it, you know, 15, 20, 30 seconds if it needs it, and it will eventually pop it up and let you know that it's finished. It's important to let it finish before you start working with other stuff, so you don't confuse the program. And mine popped up on, but again, it was in my other window, so you can't really see it, but it says define projection on the little tool pops up, and I know it's finished. So now I could close that, but I know I have one more data layer to check on the definitions, and that is the DLG data that was processed for us by the program. So let's go in there. We're interested in the LEO1. Remember, we're not going to worry about these others for now, but if you wanted to look at those others in ArcMap, you would need to define all those as well. So we'll just look at the LEO1s for now. And let's just right click and look at properties and see what it tells us. And lo and behold, and this one, remember, is vector data, so it looks a little bit different. but we see that right away, if you've got coordinate system selected, it tells us that it's unknown. So the DLG to Shape program is really good about handling zip data, and it helps sort through. It knew what the metadata told it about the projection, but it doesn't automatically define it for you. So it knows how to process it correctly, but we still have to define it in ArcCatalog. So in this case, we'll just go right back to our define projection routine, and we'll take that file, and I'm just going to drag it up here. And it's unknown, so we'll select that. And we know that this one, remember, is in UTM, NAD 1927, in zone 16. So that's what we want to select. So we click on projected. And if it were geographic, remember, we would click the other one. If it were latitude, longitude, remember, latitude, longitude, and geographic are the same. So keep that in mind. Here we're at UTM, so we want that. We want the NAD 1927, and we want zone 16. Say OK. Click OK again, and it will process that a lot more quickly since we ran the tool earlier. So it already processed that for me. Now let me show you on the other one. Let's go into our hypsography, and I'm going to show you just another quick way to define a projection for that. And feel free to use the tools for now out of the toolbox, so you don't get confused. But a lot of you have used that for a while now, and there's another way you can do it, so I'm going to just show you that. You can right click on that and go to properties, and since it's undefined here, then I can just go ahead in this top dialog and pick the one I want. Okay, so I know it's projected, I know it's UTM, it's 1927, and zone 16, puts it in there. I can click apply, and right away it pops that in there. It's a bit more, it's a bit quicker. It's maybe not as logical as going through the steps as we did earlier, given that you're trying to learn the terminology and so forth, but it is a little bit quicker, and I can go back in properties and verify that yes, it did define it, so it's showing it up there. So that's another way you can do it. I don't want to confuse you. Feel free to use the tools to do it every time if you like, but that is another way you can do it. Now in this case, these are in 1927. We know we're going to get an issue when we try to pull those into ArcMap. It will load them, and to be honest with you, the newer versions of ArcMap is so good about their reprojecting on the fly that they handle even the 1927 datum transfer pretty darn well. So you could get by with putting that in, but it wouldn't be quite right. I mean, there are differences, and where some of these might not show up as bad until you may be doing some analysis down the road or something. So to be consistent, I'm going to recommend that if you get a 27 and you're using it with 83 data, then you probably want to reproject that 27. Now another reason that we want to do the 27, one is to be consistent and minimize errors down the road. Two would be I lost my train of thought. Two would be to get the keep from getting the error message from popping up at you all the time. And again, and really you want to go from an older datum to a newer datum where you can. And the other point I wanted to make is that it's always better to reproject a vector data instead of raster data. For some reason, I found over the years that the Esri reproject doesn't work as well on the raster data for some reason. And it might not be an Esri thing, it might just be the format that the raster data is stored in. It might make it more difficult. Because the raster data, remember, is basically a picture that's been pixelated, and the projection information is based on the upper left corner of that picture. So in this case, we're dealing with a quad. It's basically taking the coordinate of that upper left corner of the quad and shifting it a little bit, and shifting the pixel size a little bit. It's not actually modifying the picture, okay? So therefore, it's really hard to get a good reproject on a raster data. So the rule of thumb is try to only reproject vector data if possible. just because it's I think you just get a better job with that than you do with raster data. And then two, where possible, go from an older datum to a newer datum. So that's some rules of thumb to keep in mind. Now we'll actually reproject that, and let's go ahead and open the first DLG file again so we can see that folder. And then the tool we want this time, and we already ran our define projection. Now we want to go into features here and run the project tool. And I think I mentioned elsewhere that I wish I just named that to reproject, but technically that is what we're doing. We're projecting it now. Before we were defining it, now we're projecting it. But I like to look at it as we're reprojecting it, because we're taking it from one projection and putting it into another projection. Okay, so just keep in mind that you never want to run this tool until you have first ran the define projection, because you always have to, the Esri program has to know what projection it's in before it can reproject it. So think of it that way, and that will help. So we're going to run the project tool on just those two DLG layers for now, and everything else is in a 1983 datum. So we'll put that one in a 1983, and then it should be consistent and everything should work then. So let's take the LEO1 file, the first one again, drag it up here and drop it. And it sees the projection that we currently have defined. It knows it's 1927, UTM zone 16. And it goes in here, it gives it a new name, and it wants to put it into a geodatabase by default, which there's some good reasons for doing that, but for our case, we don't want that. And notice it's actually putting it in an entirely different subdirectory system. So we want to change that. We want to put it where it currently is stored right now and just give it a different name a little bit. So let's go ahead and do that. And I want to have to route over to my GIS 101 folder again. And it will probably remember this for the second one after we get to that. And we're dealing with DLG data, so we'll go in there. And we're dealing with this ozone, this first one, that's the hydrography, is the one we're dealing with first. And it sees the files there. And what we want to do is give it a little bit of a different name here. So let's just call it, let's just call it hydro. Actually, we'll call it hydro for hydrography. And I'm going to call it hydro 83, just so I differentiate that from the 27. I'll probably come up with a better name than that, but that's what I'm going to call it for now. That tells me it's a hydrography layer, keeps it less than 8 characters, even though it would be okay given that it's vector data to be a little bit longer, but you don't want any spaces in it regardless. And the 83 tells me it's an 83 datum instead of a 27, because when I see DLG, I think 27 automatically, unless I know I've modified it myself. So this name is not the same format as the others. So when I see this, it would jump out as me as that's something different. So I'm going to just stick with that for now. Click on Save. And now I want to tell it the coordinate system I want it to be in. It knows what it is up here from where we defined it. Now here we want to select the one we want it to be in. And so we're going to stick with the UTM, okay, but we're going to go to 83 instead of 27. We want to make sure we stick to the zone 16. We'll click OK. And since it's in a different datum, then it is a good idea to run a geographic transformation on it. Okay, and it's already sort of picked one for us here. And it's using the NAD 1927 to NAD 1983 NADCON. And so if yours did not pick that automatically, it's probably picking that up from where I've used it before. If yours is blank in here, then just click this drop down and then pick that top one right here, NAD 27 to NAD 83 NADCON. NADCON is just a certain type of procedure, a certain standard that it's using. And you can see there are other ones in here as well. But for our use, we're going to use this 27 to 83, leave it on NADCON. And again, yours might already have it picked. If it does, just go with that. If not, select that one and it should show up here. And that's all we have to do. Once we've done that, we click OK. And it will run for a minute, and then it will pop up the little dialog like it did with the project tool to let us know that project has ran. And again, it takes it just a few minutes for the first time you run it, and then it will pop up. Mine just popped up in my other window, so I know it worked. And I can go in and it's actually the file is showing up here without me even having to refresh it. If yours doesn't show up, then click on refresh, but it should show up automatically. I can right click on that and look at properties just to verify, and it tells me it is in 1983 UTM. So that's where I wanted to go with it. Again, remember, it's very important that it's defined before you try to do a reprojection. And go ahead and do the same thing on the next file. And I'll pause the video now because we're already up to about an hour and a half here. While I was processing that, I wanted to point out that it did not remember what I used for the path on the last one, so I did have to go in and select that again. But when I selected the drop down, it did remember where I was before. But be careful you don't store it in that same folder, because we're dealing with the hypsography data now, not the hydrography. So I want to move up one level and move back into the hypsography here instead of hydrography and save it in there. And in this case, we'll call it HYPSOG for hypsography, and I'll give it the 83 like I did before. And save, and we'll pick our coordinate system again. And in this case, notice it's saying that it is unknown, which that's a red flag to me, because perhaps I forgot to go in and define that one before. Thought I did, but maybe I accidentally defined the wrong one. I might have drugged on the list over here, I might have drugged the NaO1 instead of the LeO1. But this is sort of a red flag here. But let me back up, because it's showing it up here. It did see it as the NAD27. I guess it's just giving me the unknown here because I haven't defined it, the projection. I guess it did that on the last one, and it's a late hour of the night now, and I forgot that. So we're good, because actually I can see here that it did see the input coordinate system as NAD27. So we're fine. So just go ahead and click on projected, UTM, and this time we want NAD83, and we'll pick zone 16, okay. It loads that for me down there. What threw me, I guess, is it had automatically put that in from the first time, but it didn't this time. So we've got that. But again, I know we were good to go because it shows the input system here, and so it's reading that from the file. So then we'll just say okay, and it should process this one a lot quicker since we just ran the tool a minute ago. Yeah, it's still working though on my end. There, it came up now, and it processed it. So I'm going to close the toolbox. If I want to, I can verify again that this new file here is set up with an NAD83 now. So we've got all of our datums the same, except for those couple 84s that we had from the sample data. Again, that was okay. We're just using that for reference data anyway. This is the data we processed, the DOG, and then we got the DOQ and DRG, and those are the important layers that we had to define and so forth. So we've got all that done. We're basically done with our catalog now. And we'll move back into ArcMap here in just a second. I'm going to pull up on my end, I'm going to pull up the steps again and just review and make sure we haven't forgotten anything. So I've opened up the project exercise again here, and we went through several steps here with the last part of the video we did here for a while. We got our DLG data, and we processed it with the DLG to shape in step 8. And step 9, we went through and did a little more data organization. We created the subfolders for the DRG and DOQ and so forth. And here's an example of what it should look like on your end in the subfolders. And then we inspected and we processed the data in our catalog. We made sure everything was defined. And in the case of the DLG data, we performed a reproject on that data. I'm highlighting here as we go along just to double check everything. And so we reprojected it, and then we closed down our catalog. And we're ready now to go back into ArcMap and finish up our project. So we just got a couple more steps here to go, a few more. And so let's move over here and go ahead and open up our the ArcMap that we had open before. And here's a project we had from before. We had saved it, And so now let's go ahead and load the new data that we downloaded and processed into here. So we want to route back up to the EXER2, and let's just go ahead and load the DRG first, and we add that in. It should add in with no problems, and you saw it pop up for just a minute and go away here because my topo index has not been set to clear. We set the counties and we to clear, and we set the state boundary to clear. Now let's go ahead and set the topo quad boundary to clear, which is hollow as well. We'll just leave it with the width and everything it's got by default. You should be able to see it, and now we can see our DRG file lining up right into that quad. And in fact, we can zoom in a little bit if we like, take closer on that quad, and we can see it lines up really well with the actual lines. Now, the lines of the index. So let me just for fun, let's set that index to red so you can see that, because the black on black is not showing up really well. We set that to red, and we can even thicken that up a little bit just for this example. And you can see it lines up right against the green on the topo index, and the black that you see is the edges of that topo quad, where it was basically warped just a little bit whenever it was projected initially before we got it. The vendor projected it, and that caused it to distort a little bit from the original square that it was in, and so you've got this edge effect that's now black because there's no data there. But if you notice with our quad index, it lines up really nice up against the green of that, and the black is outside the red lines, which is what we would expect. So that lines up really well, so it looks good. So let's go ahead and load the DOQ layer now. And that one also lines up really well. So we've got that in there. And of course, you can't really see both of them. I pointed that out in the instructions, but we were doing this just for fun. You would normally be choosing one or the other of these for your project. You wouldn't really necessarily need both of them loaded in the same data frame because you can't see them but one at a time. But for our use here, we just wanted to practice working with that data a little bit. So, so now let's go ahead and load in the DOG layers. And things should get real interesting when we do that. So take the DOG, let's load the hydrography, which again, remember, is the contour lines. And the one we process, remember, which is important, is the LEO1. The others, if you try to load them now, we didn't even define them in our case in this example, so they wouldn't load properly. So if you want to load those and see what they look like, then make sure you define them before you come in here and load them. And in this case, you'd be better off to actually define them and then reproject them as well. So a little more tedious, but if you want to do that, that's fine. For our case, we'll just take the LEO1, add that in, and it's warning us here that it's 1927. So did anybody catch that, what I did? I went and tried to load the original, not the one we reprojected. So let's do the X here, and it may actually try to load it. Yeah, I was going to say it might load it, and it's the hydrography. I'm sorry, not the hypsography. It is the stream data. Now it loaded it, and it actually looks pretty good, but I loaded the wrong one, right? So I'm going to remove that, and let's load the one that we actually created, which was the Hydro 83, right? That's the one we reprojected. So that's the one we really wanted to load. So we load that in, and that's the streams. I apologize again, it's not the contours, that's the streams. So I'm going to set my symbology a little different. Let's make it blue, and I'm going to bump it up a little bit on the thickness so it will stand out on there a little bit. And let's just turn our DOQ off, so we've got the topo map in there. And before we load the other layer, just for fun, let's zoom in a little bit and see how well this lines up. Always a good idea to check that. And it also shows you what you have a little bit. So if I turn that back off, here's the original topo map, and I can see there's a blue line for probably an ephemeral stream here. I'm not sure. It might be a year-round. Kind of hard to tell from here. It flows into a Daddy's Creek here, which is a more major stream. And there's a pond or something that's been created up in this area. Looks like it's put in purple, which on the topo maps, the USGS adds anything in purple for an update. So you can see there's an entire road system in here that's showing up in purple, And that's because this original topo map, if I had the collars on it, I could tell the date it was created. But it was created some years ago, maybe many decades ago. And then it was revised, what they call photo revised, based on aerial photography that they flew more recently. It was revised and these roads were added to it and added in purple, as well as those pond features. So for fun, let's just turn our DOQ back on and see if that shows up. And indeed, we can see there's a pond there, and here are fresh roads that have been put in since that DOQ was initially created. So it's kind of neat to see. So that's what's going on there. We just randomly went into this area. Here's another stream. Now let's turn our hydrography back on and see how well it lines up. And I just wanted to point this out to you that it really lines up nicely. If you zoom in even tighter, you can see that even better. And it's important to notice because this is very detailed. At 1 to 24,000 is about as detailed as you're going to get free data at. And there's some other data we're going to use later called Tiger data. And while it's got a lot of advantages to it, one of the disadvantages is it's not as spatially accurate as the DLG data. Now it's getting better, so that's changing because over time they're using better and better data to create that Tiger data as well. But as a good rule of thumb, the DLG data is not only better in terms of spatial accuracy, but it's more thorough as well. In other words, it will have a lot of these streams that don't even have names, like this little branch. This one is Wolfden, it's got a name to it, but if you come on this fork out here, there's no name on that, and there's a chance that that might not even be included in the Tiger data, and yet it is here. So it's more thorough, and it's usually more accurate spatially. And so that's part of the reason I try to emphasize the DOG data, because it's just a really handy data source to get in terms of more thorough data. And once you get used to processing this and playing with it a little bit, you'll get really fast at doing all these steps that we've taken an hour and 40 minutes to do here in this video. You'll do it much more quickly. And so, so it'd be real powerful knowledge for you to have. And even this new pond is outlined in blue, which is interesting. So some of the streams are there, and the boundaries of some of the ponds are there as well. So you've got water features, and on the bigger creeks and bigger creeks and rivers, oftentimes they will have two lines. See how, notice they've got both sides of the creek in this case, and they would do it on rivers as well. But both sides of that boundary, if I turn that off, you can see both sides of the creek are detailed in the DOG layer as well. So you get a lot of detail gets captured there with that information. If you turn on your imagery, you'll see it's showing up in there. It's wider too, and notice a little bit of difference. See, it's off a little bit right here. Okay, so none of this is perfect, but it's really close, and it's hard to say 100% how far off it is because the trees, the angle of the aerial photography might be such that this canopy of tree is actually hanging out over the water or something, so it might not be off very much at all. But it does appear that in this area right here, at least where I'm moving the mouse, it's off a little bit. But again, it's still really darn good considering the ease and with which you can get this data and the availability of the data. And there's also a chance that the aerial photography was warped a little bit in that area, and it could be that's off as well. So anyway, we've got that information in there. Now let's back up. We sort of took a look at it. You can kind of see that it is really accurate. We've got the stream data. So I'm going to zoom back out to the extent of one of those quads. So we're back out to this level. Now let's load our contour lines, and that is the hydrography, not the hypsography. I'm sorry, it's the hypsography, not the hydrography. It is late, and I'm getting tired. So we'll load the one that we processed and reprojected, and add that. We should get a bunch of lines here when we do that, because we're actually getting all of the topo lines off of that topo map. So where this data layer is available, it's not available for some of the quads, as I mentioned earlier. That's true in general with a lot of the different layers. Some of them are available more than others. But where it's available, this is a really useful data source. Both of these are really. But you can see just by sheer number alone, you can imagine how long it would take to heads-up digitize that kind of information. Later in the course, I'll show you yet another way to derive this information that's pretty similar. It's not as accurate as this, but it's very acceptable in a lot of cases, depending on the scale of your work and how much volume of data you're dealing with. But where this is available, it's a really nice layer. It is a vector layer, and what I'm going to show you from later on is derived from a raster layer. But here you can see it lines up also really well. Not perfect, but really, really well considering. And I've made it about the same color here, so if I shift the color just a little bit, so you can see it kind of stand out. You can see in red is our vector data, and you can see it's pretty close. It's got the general shape and form of the contour lines as well off of the topo map. So the USGS has basically extracted some real powerful vector data from this raster data source, and it gives us some interesting things to work with. So if we look real quickly at the attribute table for those layers, for the hypsography, a nice thing about it is, let me expand this a little bit, and you'll see it has elevation field in here. Now it's showing some zeros in here, okay, but if I scroll down you can see there's actually some elevation in there. Now those zeros, interestingly, if you highlighted all of those zeros, so you selected the first one, you could run a select query as well, but in this case, since they're tend to be organized here by default sequentially there, I'm going to just scroll down in my table and hold my shift key down and highlight. That highlights everything. I clicked on the first one and then held shift key down, clicked on the last one, and it highlighted everything in between. And so if I go out here and zoom back out to the extent, you'll see what the zeros represent, which is usually your boundary around the quad. So yeah, you'll see, notice it highlighted in blue there. Not sure how well it's showing up on video, so I'm going to zoom into a corner here. And you can see it's highlighted there in blue. And that is the layers. If I go in and clear that table, you'll see it go away, just so you can verify that is what's highlighted. But notice the blue rectangle around there. That's what we've highlighted in here. So if we go in here and clear our selections, then you see it goes away. So that verifies for you that was. Basically what it is the contour lines, they include the bounding rectangle around the quad map as well. So if you're using this data in a project, you may or may not want to keep that. A good way to get rid of that layer, you just edit this vector layer, go in there and select all the zero elevations like we just did, and just delete those, and that would take that boundary away. If you were working with several quads, that would be an issue. You wouldn't want that boundary in between them because you'd want your lines to appear to be continuous, and so you'd want to get rid of that boundary. So they've just included that in there, and that's why you have some zeros in your elevation. But what I wanted to point out here is it's one of the really useful things is that you have that elevation. Can you imagine the time it would have taken to go in by hand and figure out the contour interval here by looking at the topo map and figuring out which elevation each line is? It would take you forever. And I mean, there's 2,032 records in here. So that's a really useful information that comes out of the DLG data. Other than that, most of this is not going to be very relevant for you right now. And later when we look at the Tiger data, you'll see that there is some other information in the Tiger data that is useful as well for you. And so we'll look at that at a later date. But for now, just remember the elevation is included in the hydrography data from the DLG, and that's useful. This other information is basically we're not going to worry about it right now, but it's your topology. So it's basically topology data, and it's telling information about what's to the left and to the right of different nodes and polygons and things like that. So just don't worry about that for now. In fact, you could even take that out if you wanted to. But the elevation is useful, and I wanted to show you that. Now, on the flip side, if you look at your hydrography data, okay, we turn that on, there's not much there. You just basically have that topology information. These links tend to be not very useful because you don't know what units they're in. Are they in meters? You would think they would be because you're dealing with a UTM layer, and UTM is usually in meters, but we don't know that for sure. We didn't calculate those, and it's not in the metadata. If it is in the metadata, then you can trust it a little better. But the length is something you would probably end up wanting to calculate yourself at some point. So really, there's not a lot of good attribute data in here. On the flip side, if we had the Tiger data, a lot of it gives the names of these streams, at least where they're named. You know, a lot of them are not named, especially in the DLG data, but all of the named streams will have names in them in your Tiger data. So this layer here, the DLG, remember, is very good because it's spatially accurate. It's got the detail in there as well, but on the flip side, it doesn't have a lot of good attribute data with it. Whereas our Tiger data has good attribute data, and it might not be quite as spatially accurate. So there are ways to use both of them in the same project and get some advantages out of that. I just wanted to make you aware of that though in here. So we've got the good spatial accuracy, which is the big thing that comes with the DLG data. And on some of the layers, like the hypsography, we have the advantage of having elevation in our attribute data as well. So there we go. We've got that. We've verified. We've kind of visually looked at it and compared it. It looks really good in terms of accuracy, and you can see that now. Everything lines up really well because we did our defines on the projections. And in the case of the DLG data, we did a reproject, and so everything is lining up nicely. We've basically got a project that completes the steps that we were looking for this exercise. So we are good to go. I'm going to zoom back out to the polygon for that bounding rectangle, and let's just change our hypsography back to a kind of a brownish tan color that would be a little closer to the actual contours in the DRG data, and separate them a little bit from the streams. In fact, we could drag the streams on top of the hypsography if we wanted to, and that will make them stand out a little better. And you can tweak this a little bit. You can play with your symbology to get it where you like it a little bit. Don't worry about spending a lot of time with it. The main goal of this exercise was to get you to process that data, get some practice on doing your defines, and in that one case, doing some reprojecting, and basically just building a nice simple project for an area of interest. I also mentioned about doing a bookmark for an area that you were most interested in. In this case, if I look just on the topo map where I can see it a little better, I can zoom in. Let me keep my cities on so I can, actually I'm not seeing the detail from the cities anyway. I was going to zoom into the Ozone Falls area. And I know I can see Interstate 40 going down here, and I know it's south of Interstate 40. So I'm going to, and I just know this from being there. You'd have to kind of look around a little bit to find the area you're interested in. And there's Ozone Falls. I can see the little community of Ozone. Here's Ozone Falls. So I'll zoom into this area a little tighter. There's a natural area there. And I'm going to make a bookmark for that. So I can go up here to Bookmarks and Create Bookmark. And I'll just call it Ozone Vicinity. I can spell. Say OK. And now the nice thing with that is I can be zoomed out to wherever I want to in there. And I can real quickly jump right back to the ozone vicinity by clicking on my bookmark and click the ozone vicinity, and zooms me right in. So that should be about it. I'm going to go ahead and save, which, by the way, you probably want to save this a little more regularly than I did in this example. Again, ignore this dialog. I'm not used to that popping up. It's because I have another utility running in the background on this that I have. So that resaved it, and so I can close the ArcMap project now. So before you do anything with zipping up your files to turn them in, you want to make sure ArcMap is closed and ArcCatalog is closed, so you don't have anything out there in temporary memory or any files that are open or anything weird going on. Close both programs down, and actually before I close it, you need to create a snapshot. So I didn't do that, but I'm assuming you'll remember and know how to do that. Just create a snapshot of your project and zoom in on the area first that you're interested in and do the snapshot. And that lets me know you've done it. If there's some problem with your files, I can at least see your snapshot if you got to there. And then you want to zip up the data and save it. And this, I'm trusting that you did not get the county data, so your file should be manageable with this upload. I'm having you zip up a little bit more just so you get used to it, because on the exam you'll be zipping up a little more. And in this case, we're already in the EXER2 subfolder, and we do not want to include the archive files in your upload, because that's just repeating data, right? We've already unzipped it and processed it. So that's for your use only. Just keep that for safekeeping. When you do the zip for this, just select the other folders and your exer2.mxd. So basically I clicked once here on this top file with the DLG, leaving off the archive, and went down to the last file, held my shift key down, and it highlighted everything. Now I can, while I'm on top of any of these layers, you have to be on top of one of them when you do this next step, but I'm going to right click and it should pop up a little dialog, and I can click on, if you're running 7-zip, just go to 7-zip and then click this option here, add to exer2.7z. So it goes ahead and it names it for you all the way in a very handy way. It goes ahead and gives you the EXER2 name. Or if you're in WinZip, just go in there and you've got the same thing, add to EXER2.zip in this case. So I'm going to pick that one since I have the WinZip. And it's going to zip it up. It's loading it in my other window, so you can't see the dialog right now, but it's processing it. It's about 50% of the way this fast, so it goes pretty quickly. And then when it finishes, you can look and see this is the file that you want to upload to the Dropbox. Just this one file and your image file. If your image file was here and you saved it by the MXD file, just include it in your zip, so you only have to upload one. But you can see the size here. It's about 22.5 megs. So actually, the 22.5 megs is going to probably be too big to upload in this case. Because the Dropbox used to let you upload files that large, and it will let me upload it, but it won't let you upload them. So this is something important to, hopefully you're picking this up out of the video before you have the problem in doing it without the video. But if your file size exceeds about 16 meg, then you're going to have to break it up into pieces and upload it that way. And I apologize for that. It's just a limitation in Momentum, and I try not to have you upload big files for the most part. And the reason this one's larger is because that we got both the hydrography and the hypsography on top of that, and we've got two raster layers. But I would bet it's probably the hypsography data that's causing our problem. But in this case, since it is, and I can see it's already bigger, so there's no point in trying to upload it. You'll just waste time. It will try to upload and then it will eventually crash. So what I'm going to do in this case, I'm just going to delete this zip file and take it out, and I'm going to zip them up a little bit separately. Let's zip up the DLG. We'll zip it up by itself, this case, and just see how large it is. In this case, instead of calling it EXER2, I'm just going to leave it DLG.zip. That defines, at least I know that's the DLG folder on my end when I see that file. I apologize again for this. It's a little bit tedious, I realize. And that's 10 megs, okay? So now I'm going to take the other files that I need and highlight them, and I can hold down my control key instead of my shift key and actually select the files and folders I want. Because you don't want to re-zip the DLG that you've already zipped up. So I've got my DLQ, DRG, and the MXD file. That's all the rest of the files. Now I'm going to right click and let's just add that to, and this time it's calling it EXER2 zip because it's naming it after the folder that it's in. And so you can leave it that way, or you can just say add the zip file and give it another name if you like. And it's a little confusing, I know. I apologize for that. I'm just going to let it go ahead and upload as EXER2 for now, just for sake of time. And it's going to be right at 11 megs, it looks like. So I can upload each of those separately just fine. You can upload multiple files as long as they don't exceed 16 meg per file. So you should be able to upload both of these zip files at this point. Just do them one at a time. Upload one and then upload the other one. So that's the way. And if you have a problem and they're just too big and you can't handle it, then just leave one of your raster files off in your upload, and just, you'll have it captured in your screenshot anyway. So I'll know that you did it. I basically just wanted you to get used to working with a little bit larger files and just see some of the little things that pop up like this. This was sort of unexpected. I did this on the fly. And again, if I had just got the hydrography data, I probably wouldn't have had that problem. But since I got both hydrography and hypsography, that caused me to be a little bit larger on the file size. So in your case, if you only got one of them, you're fine. But again, remember, when you initially zip it up, if it's more than 16 meg, then you're going to want to split them up some way. And it's nice to split them up in a way that on my end I can recreate it pretty easily. And since I gave you step by step in this case on how to make the subfolders and everything, then I should be able to rebuild it on my end just fine when I'm looking at your work. So in this case, we'll upload those 2 zip files and we're good to go. I'm going to assume you remember how to do that in the Dropbox, so I'm not going to cover that here. I think we've been really thorough. We went, looks like exactly 2 hours here. I apologize for the length, but hopefully this was helpful to you, especially anybody having problems with it. And I would just say this, practice with this material on some other exercises. You can just create your own exercise if you like. Just pick another area to work with for practice. Run through this same example that I've done here if you like, and then pick another area of your own. That's really the best way to learn it, is to just sit down and just practice with it. But I made this video because I was afraid that some of you might be just really stuck on a couple steps, and hopefully this helps and covers all the different scenarios where people might be having different problems. So I'll end it here, and hope you enjoyed this exercise. I just point out again that after you've completed this, the really neat thing is, whether you realize it or not, you'll be able now to process some important GIS data for anywhere in the country that you want to. And so I think that's pretty powerful for you to be able to do that. And on the exams coming up, you'll get a chance to practice this kind of stuff on a different area of the country. And so that'll give you some more practice with it as well. But in between now and then, practice on your own. Pick some areas you're interested in to play with. Start building a few sample projects of your own. And just kind of have fun with it. See what you can do as you're learning more information. You can get more data to add to that project. And in some of your classes outside of the 101, you'll be doing class projects, and you'll be able to use this information for those as well. So, okay, I will see everybody next time. Thank you.